breathing is cyclic, and a full respiratory cycle from the beginning of inhalation to the end of exhalation takes about 5 seconds. The maximum rate of airflow into the lungs is about 0.5 liters per second. This explains in part why the function f of t is equal to 1/2 sine of 2 pi t over 5 has often been used to model the rate of airflow into the lungs. We want to use this model to find the volume of inhaled air in the lungs at time t. So, we know that the volume of inhaled air in the lungs at time t is given by the following. So V of t would equal the integral going from 0 to t of the function f of u du. Okay, so what are we going to do? We're going to go ahead and then represent the following. So we have the integral going from a lower bound of 0 to t, and so what we're going to do is replace this variable here with, we're going to substitute u in for t into this function. So we end up getting 1/2 times the sine of 2 pi u over 5 du. So now what we're going to do is we're going to go ahead with a substitution. Okay, so because we're already using u as a variable, we're going to let v equal our substitution, which is 2 pi over 5 u. And now we're going to take the derivative with respect to u. So we're going to get dv, which is equal to 2 pi over 5 du. Okay, so because we're substituting in for du, we're going to have to divide both sides by 2 pi over 5, which is the same thing as taking the reciprocal. So therefore, 5 over 2 pi dv is going to equal du. Okay, so now in step number 4, what we're going to do now is we're going to rewrite this with our substitution. So we're going to rewrite this question, so 0 to t, and we have 1/2 factored out, and then we have the sine of 2 pi over 5 u du. And now let's put in our substitution. So we have 1/2, and therefore we have the sine of v, and du is equal to 5 over 2 pi dv. Okay, and then we got to rewrite what our upper and lower limits are according to v. So we know that v is equal to 2 pi over 5 u. And so then substituting t in for u, we end up getting 2 pi over 5 times t. And same thing down here. V is going to equal 2 pi over 5 u, and we're replacing u with 0, so this is 2 pi over 5 times 0. And now let's go ahead and write down what our substitution is. So we're going to factor out, let's see here, the constant 5 over 2 pi times 1 over 2. So we're going to get 5 over 2 times 2, which is 4 pi. We have a lower bound of 2 pi over 5 times 0, which is 0. And our upper bound is going to be 2 pi t over 5. And then we're integrating the sine of v dv. So now what is the antiderivative of sine of v? So we know that the antiderivative is negative cosine of v. So we have negative cosine of v going from 0 to 2 pi t over 5. So now let's go ahead and substitute. So we have 5 over 4 pi. Okay, and what we're going to do now is then plug in our value here. So let's go ahead and do that. So we have negative cosine of 2 pi t over 5 minus negative cosine of 0. So now that we have that, let's go ahead and continue. Okay, so what do we get over on this side? We get 5 over 4 pi times negative cosine of 2 pi t over 5, and that's plus the cosine of 0, which is 1. So if we want to rewrite this, we would have 5 over 4 pi, and just reorganize this, the positive 1 minus the cosine of 2 pi t over 5. Okay, and let's go back to the question. It's asking us, use this model to find the volume of inhaled air in the lungs at time t. So this is the model here. So whatever time t is would be the following. So this would be the result, and the units would be liters. So therefore it would be 5 over 4 pi times 1 minus the cosine of 2 pi t over 5 liters, and that would all depend on whatever t is, and that is our solution.